Mr. Koz, yeah, you already know. Mr. Koz, break it down to the flow. Mr. Mr. Koz, you already know. Mr. Koz, break it down to the flow. Yeah, Koz teach me now, so the science stuff I get it. Yeah, all types of energy, potential and kinetic.
All right, we're going to take a minute and we're going to solve the skier problem on an incline, and we're also going to include friction. Now, the goal of the problem is going to be to determine the acceleration of the object. The object can be a skier, a sledder, a box, it really doesn't matter, but our goal is going to find acceleration, and by doing that you can also do kinematics to find final velocity or find the change in position. Okay? So as we look at this, let's look at the things that were given to you. Normally this would be in the form of a word problem, but in this case I'm just drawing up the picture. In fact, we're going to add an angle to this. We're going to say that this is a 40-degree incline. That would be given to you in the problem, and so I'm going to draw my incline, I'm going to draw my object. It'd give us a mass of 55 kilograms. It's different than weight. That is our mass, and a coefficient of friction of 0.3, and our goal is to find acceleration. So the first step that we're going to do here is we're going to label our forces. As in all objects on this planet, we've got weight that is going down. Now, it's important that when we do a free body diagram, all of those forces, all those vectors should be coming right from the center of the object. Weight is going down, and the other force that we have, and I know this because it's on a surface, is the normal force. The normal force is always perpendicular to the surface. And lastly, because there is a coefficient of friction in the problem, I know that I have friction. And friction's going in the direction opposite of the way the motion would go. So this object wants to go down the hill, therefore I know friction must be going up the hill. Okay? So now I've got my free body diagram. This is going to be what we're using to solve all the stuff in this problem. Now we need to take a look at this free body diagram and look at where our x and y axis are. This would be our x-axis and this would be our y-axis. And looking at that, I find that weight is not going in the right direction. So we're going to have to break that into its x and y components. First, though, we need to actually solve for what is weight. We know the equation for weight is mass times gravity. And you've been given that the mass is 55 kilograms, so weight is going to be 55 kilograms times 9.8 meters per second squared. You get a weight of 539 newtons. Now that's going to be important for us to do our trig, but once we do the trig and we get our components, you won't use that weight anymore. Now, we do notice that weight is not going in the x or y direction, so I'm going to break it down to components. You're going to have a y component. That's my weight in the y, and an x component. Notice this y component matches up with my normal, and this x component is opposite of friction. It's going with the incline. Inevitably, our goal is going to be to take Wx and subtract friction to find the net force. Now, to do the trig, to solve for this over here, we're going to go ahead and let's start out by solving for Wy. Wy is our adjacent side. Our angle of 40 degrees here is the same as this angle right here. This is our hypotenuse. This weight is 539 newtons. That's 539. And we've got this angle. This is hypotenuse. That's adjacent. We're going to use cosine. So cosine of 40 degrees equals Wy over 539. When I rearrange that and I solve, I get Wy to be 412.90. Now I believe in my calculator I got 412.897, but I went ahead and I rounded that. Now to find Wx, and I'm just going to do that to get it out of the way, this is my opposite side. I'm going to do sine of 40 degrees equals Wx over 539 newtons. When I rearrange that, I know that Wx is 346.46 newtons. Okay. These are going to be important. In fact, at this point, you've almost done most of the problem, because now you know this force, you know this force, And from those, we can find out the rest of them, and then we can start summing our forces to get the net force. Why do I care what Wy is? Because I can assume that Wy and the normal must be the same. And that's because this box is not accelerating off the hill and it's not accelerating into the incline. That means these must be balanced. They must be the same, and that's why we solve Wy. So I know normal must be the same as my Wy. This must be 412.9. Great. Why do I care what the normal is? Well, I've got Wx down here. Wx is 346. I know that there's a force going up the hill. I need to solve for that, and that's friction. Friction is mu times the normal force. You were given mu in the problem, but that is not the actual force of friction. It's the coefficient of friction. I need the normal force to solve for friction. Well, I now know the normal force. Friction is going to be my coefficient of 0.3 times the normal of 412.90. When you solve that, you get friction to be 123.87 newtons. So now you have friction. Now that you have friction, and you know Wx is going down the slope and friction is going up the slope, to find the net force, you're getting the sum of the forces. You're taking this friction and subtracting it from Wx in order to find out what the net force is going down the hill. So to find the net force, you know that it's going to be Wx minus the force of friction, which in this case is 346.46 minus 123.87 newtons. When you subtract those two, you get an F net of 222.59 newtons. That right there is really one of the major goals of this problem, is find the net force. Now some people, when they want to find net force, immediately they go to F net equals ma. And I understand that. But first you're looking at your picture. You're summing the forces. You get a value. Now we have a value. And from that, we're going to say F equals ma. And so we're going to say F net equals ma. We know the mass. The mass is 55 kilograms. We now know F net. It's 222.59. And when you rearrange and plug these two in, you get F net over m. 222.59 over 55 kilograms. Your acceleration, once you put this all into play and you've calculated 222.59 over 55, you will get 4.05 meters per second squared. From the acceleration, you can go through and you can solve for Vf using maybe the timeless equation. You could solve using the acceleration equation, depending on what they give you. If they give you time or if they don't give you time, you can use the position equation to figure out how far they've gone. One of the more complicated problems here, the main idea, find the forces going down, find the forces going up, subtract them to get the net force. You got to do a little bit of trig to get there.